Right, so next let's look at exercise 47. So here we are given two inequalities. One of them involves the absolute value. We have been asked to say something about the variable x. That is, we have to solve these two inequalities simultaneously. So let's see the solution. We know that this is equivalent to these inequalities, that x must lie between -3 and 3. It can take the values -3 and 3 also, but it will not exceed 3, or it and at the same time it will not be strictly less than -3. So if we also have this inequality, then x has to be greater than -1/2 and less than or equal to 3. That is, the set of all real numbers x for which this is true and at the same time this is also true is this interval, this half open interval. That is, it can take the value 3, but it will not take the value -1/2. Then the next one, (48). Graph the inequality. Now this one may seem a little tricky. At first glance, you may not be able to figure out how to do it actually. But we have to divide this up into cases depending on the sign of x and as well as y. That is, whether x is non-negative and or y is non-negative. Such things have to be considered. So here we are just going to draw the graph and give you the explanation, but you will have to describe with words what is being explained here. So let us carefully draw two axes. Our x-axis, where say this is the origin, and from the origin let's consider this as 1 unit distance. On that side also we identify this. Okay, so this is the positive direction of the x-axis, this is the positive direction of the y-axis. This is the origin, this is 1 unit length. Okay, so we can in fact draw the, say what the coordinates of these 4 points are. Okay, now there are cases, these are the cases x is greater than or equal to 0 or x is less than 0, and just like that y is greater than or equal to 0 or y is less than 0. Combining these things, we will get 4 situations, 4 cases will be there. Number 1, of course, is the case where both x and y are non-negative. In that case, this inequality will reduce to this. Because if these are the situations, then both absolute value of x and absolute value of y are equal to x and y respectively. So that's why we have this. Now how do we draw the graph of this? In fact, it's not an equation, it's an inequality. So to do that, you try to draw the graph of this equation, which you can either do by plotting points, or if you are aware of coordinate geometry a little bit, where at least you know what this type of equations represent, then you can easily see that this will represent a straight line. What type of straight line? That you can see quickly by observing that both these points 0, 1 and 1, 0 lie on this straight line. So 2 points lie on a straight line, that will determine the straight line. It will pass through those 2 points. So let us draw that line here, keeping the text intact. So this is the line which is unbounded on either direction. Okay, but this is only the straight line. We don't want the graph of this equation, we want the graph of the inequality. Now what happens when you say you drew this line by plotting points? What you have already learned in school. How do you do that? You make a small table, you put some values of x and corresponding values of y are calculated. For example, you can put say x equal to 0. If x is 0, then y is equal to 1. Thereby you get a point 0, 1 on the graph. Like that, you can put x equal to 1. If x is 1, then y has to be equal to 0, and like that you put some other values of x, find some corresponding values of y. Then you consider the coordinates and plot the points on a graph paper, and you join them. You join them. I'm not going to say anything more about how to join them, because in this case we are dealing with a straight line, and you will see that you will get this straight line. Okay, now what is the expression for y in terms of x in this equation? Y is equal to 1 minus x. So that means whenever I have an x value here anywhere on the x-axis, either here or here or here, then what are the corresponding y? What are the corresponding values of y? Let's see. Since I haven't said what x is in these three cases, that is the 3 points I have drawn here. So this is a general situation, just for the sake of showing you what's going on. Okay, so this is x1, this is x2, and this is x3. x1 lies between 0 and 1, x2 is greater than 1, and x3 is some negative real number. Now the points on this line, which are the points of intersection of these vertical lines passing through these points x1, x2 and x3. These points have coordinates what? x1, comma 1 minus x1. This is x2, comma 1 minus x2. And here we have x3, comma 1 minus x3. Note, now observe the point x1. This is the y value corresponding to x1, that is the real number 1 minus x1 corresponds to this point on the y-axis, this point. That's why the coordinates of this point are x1 and 1 minus x1, according to how we draw a graph. Now, so this is the value of y for which x1, comma y will lie on this point. Okay, if you take a smaller value of y with the same value of x1, you won't get this point, but you will get a point below that point. If you take a smaller value of y than 1 minus x1, if you take a larger value of y, then you will get a point here somewhere, still on this vertical line, but not on this level, on a higher level. Okay, so what do you think of this inequality? I am going to make a statement now, see if it makes sense. The points that will satisfy this inequality, in other words, the real numbers x and y that will satisfy this inequality, will correspond to points that will lie below this line, that is on this side of the line. Why? Because any point that lies on the line, if you add the coordinates of any coordinate, okay, any point will have some coordinate that is lying on this line. If you add the coordinates, the sum will be equal to 1. For points below this line, if you add the x and y coordinates, the sum will be less than 1, because there the y values are smaller than 1 minus x1. Here, if you choose any point arbitrarily, say I choose this point, okay, it has some coordinates x, comma y. Okay, then corresponding to this point, you can imagine that you can draw a vertical line through this point. That vertical line will intersect this line at some point. That point has a y coordinate, and that y coordinate is exactly equal to 1 minus x. but our y coordinate is less than that y coordinate simply because it lies below that. So our y is less than 1 minus x, and that's why x plus y is less than 1. So for any point lying on this side of this straight line, x plus y, the sum of their coordinates is less than 1. For any point lying on the straight line, the sum of its coordinates is equal to 1. And for any point lying above this straight line, the sum of its coordinates is greater than 1. Okay, that also is true. Just to see how that is true, you take a point, say alpha comma beta. Okay, so you join means you draw a perpendicular line passing through that point. It will intersect our straight line at some point here. So the coordinate of this point, the coordinates are 1 comma 1 minus alpha. You can see that beta is greater than 1 minus alpha, because beta is a real number lying on the x-axis here, and 1 minus alpha lies here. On the y-axis. So on the y-axis, the way numbers are ordered, it increases as you go up. So beta is greater than 1 minus alpha. So that's why if you add the coordinates of this point, then it becomes greater than 1. This tells us that the set of all points for which x plus y is less than or equal to 1 is the set of all points that lie below this line and also on the line, because we have a provision for equality. Okay, I don't want to wrap this part off, so let us continue from this side. So that means, okay, let me first write the coordinates of the points, then we will say other things. I am using dashed line because this is not the graph, the region that lies here below this line and also on the line. We have other cases also to consider. So it's the first case where x and y are both non-negative. Let's now consider another case. Say x is non-negative and y is negative. In this case, this inequality will become what? X is non-negative, so absolute value of x is x, y is negative, so its absolute value is minus y. Just like the previous one, here also we try to distinguish this region. So what will happen? Here we will have to consider the straight line x minus y equal to 1. Now you just look for any 2 points from among these 4 points that whose coordinates we have written to satisfy this line. That will tell you what this straight line is. So you can see that if you put x equal to 0, then y is minus 1. Here you see, if x is 0, then y is minus 1. That means this is a point on this straight line. If you put y equal to 0, then x is equal to 1. That means this is another point on the straight line. So this straight line is this. But what will this region be? Which side of the straight line should we take? For that, you just identify one point that will satisfy this inequality. The side on which that point lies, that will be the that will determine the region for this inequality. Okay, so you can see that if I put x equal to 1 and y equal to 1, then I get, for x equal to y equal to 1, we have 1 minus 1, which is 0. This is less than 1. That means the point 1 comma 1 satisfies this inequality. So the side on which this point lies, that will be the side that will be a part of this region. So 1 comma 1, that point is here. So that means this is the side. Here for this line we have to consider the straight line and also all the points lying above it. Okay. Then there are 2 more cases. Case 3 has this situation where x is negative and y is non-negative. In this case, the inequality will reduce to this. Less than or equal to 1. Okay. So we consider this straight line. Now for this straight line, if you take x equal to 0, y is equal to 1. So that means this is a point on the straight line. And if you take y equal to 0, then x is minus 1. So that means this is another point on the straight line. So this straight line is this one. But which side of it should we take? That will determine by the any point that satisfies this inequality, minus x plus y less than 1. So we can take x equal to 1 and y equal to 0. That will do. If you take x equal to 1 and y equal to 0, then you get minus 1 plus 0, that is minus 1, so that is less than 1. That means 1 comma 0 is this point. 1 comma 0 satisfies this inequality. So it lies on this side of this line. So this region, that is the region that lies below this line, will be the region determined by this inequality. So that means below this line. Below this line, above this line. And there is one more case where x and y are both less than 0. In this case, the inequality becomes this, or equivalently x plus y has to be greater than minus 1. Okay. Oh, sorry, we have this. Now here the equation is x plus y equal to minus 1. If x is 0, then y is minus 1. So this is a point on this final straight line. And if y is 0, then x is minus 1. So this is another point. So the other line is this one. And you can see that if you put x equal to y equal to 0, then 0 plus 0 is 0. This is greater than minus 1. So 0 comma 0 is a point that satisfies this inequality. And 0 comma 0 is here. So for this line also, we have to consider the points above it and along with the points on the line of curves. So ultimately, what are we getting? We are getting the region that lies within this quadrilateral, which actually turns out to be a square, a diamond shaped, a square which is oriented as a diamond shaped region. Okay. So our final graph will be this. Okay, the previous graphs I drew somewhat large for the sake of explanation, but this one I need not draw some too large. So you can write like this: the graph of absolute value of x plus absolute value of y less than or equal to 1 is the square whose vertices are 0, 1, minus 1, 0, 0, minus 1 and 1, 0, along with its interior. So that means if you consider any point from within this square, that is in the interior of this square, and put that point in this inequality, the inequality will be satisfied. Also, any point on the square if you take and if you see its coordinates, those coordinates you can put here, then also this inequality will be true. But any point from the exterior of the square if you consider, then for that the inequality will not be true. So the solution set of this inequality is this square along with its interior. When we say square, we of course mean the points on these straight lines, and when we say interior, then the bounded region within. Okay. Next we have a graphing exercise which needs a graphing calculator. It's a device which is like an ordinary calculator that allows you to calculate numerical results, carry out numerical operations. But a graphing calculator is a calculator with a display which will show you the graph of a function if you give the function as input, and you also specify the values over which x will vary, that is the independent variable will vary, and you specify some other parameters, it will give you the graph. So let us see the exercise first, and then we will address the issue of what will happen if someone does not have a graphing calculator. Just like me, I don't have a graphing calculator, then what do I do? How can I still solve the exercise? Okay, let me write from here. I need some ink. To distinguish these exercises from others, this word grapher is there, you can see beside these exercises. So the 49th one is this: graph the functions fx equal to x by 2 and gx equal to 1 plus 4 by x together to identify the values of x for which x divided by 2 is greater than 1 plus 4 divided by x. That is part A, and part B is this. Confirm your findings in A algebraically. So this is a graphical method to solve a given inequality by, say, considering two functions which are two sides of the inequality, then graphing those functions, and then from the graph itself you will be able to see what the values of x are for which this inequality is true. Okay, so now if you don't have a graphing calculator, which I am sure most of us don't have, then you may be tempted to actually draw the graph on a graph paper, which you can do. Of course, you can make tables and draw graphs of these functions, normally how you would draw graphs. However, this is not the only exercise where we need to graph functions, and the further we go in our study of calculus, the more complicated the functions will become. You will soon see that it will take, of course you can graph any function you want by calculating its values at some points and then plotting those points, joining them, you can draw the graphs, but it will take more and more time. At some point you will see that it's better to use some graphing calculator, because the actual problem that you may be solving at that point, it should not be burdened by this just simple task of drawing graph. So for that reason, I have found this website. There are many like this, but I find this one particularly nice. Okay, let me write the URL in a new line. / calculator. You type this in your search bar, a website will open. There you will see that the website looks like this. There is a line dividing the web page into two parts. On the right hand side you will see a grid like a graph paper. On the left side you will see that there are several lines where you can type the function out. Once you type the function, the graph will automatically be generated. It will not even ask you to put values or anything. You just type the function here. There are ways of how to, there is a box you find here somewhere. There will be a place where you can see how to use symbols, mathematical symbols, which you cannot type using your keyboard. So such symbols are available in the website itself. Using them and you can find functions also there, trigonometric functions, exponential function, logarithmic function, all such things are available there. You use them to type your function out, the graph will automatically be drawn. What more is the other nice thing about this site is that you can draw multiple graphs at once. This is one function you have typed out, its graph appears like this. Some graph is there. You type another function out, another graph will appear in the same graph paper. So it is particularly suitable for this type of exercises where we have to draw multiple graphs in one place. And then looking at that graph, you will be able to see you will be able to find the values of x for which this inequality is true. So that means to solve part A, you have to go to this site, or if you have a graphing calculator, then fine, you use that and you grab these two things. So we are actually going to solve part B. On this website, this is not just simply a graphing calculator. You can do other jobs of mathematics also. Okay, you can get many things done. You explore this site and see what you find. So in part B, we have to solve this inequality algebraically. Now note that this inequality is a little different from what we have seen so far. It's because here we have x in the denominator, so we have to be careful. Now since we have x in the denominator, its value will never be equal to 0, because otherwise this function, the way it appears, is meaningless at x equal to 0. So x as a real number can either be greater than 0 or less than 0. So accordingly, two cases will arise. If x is greater than 0, then greater than 1 plus 4 divided by x is equivalent to, we can then multiply both sides by x. That will give us, in fact, if we do that by 2x, then we don't have to bother about this 2. So if we multiply by 2x, we will have x square greater than 2x plus 8, or x square minus 2x is greater than 8 if and only if x square minus 2x plus 1 is greater than 9 if and only if x minus 1 whole square is greater than 9. Now we have already seen how to solve this type of inequalities. So this is true if and only if so next what we do, we take square root on both sides. The inequality is not reversed because both x minus 1 whole square and 9 are positive real numbers. The reason this is not equal to 0 is because if x is equal to 1, then this becomes 0. So 0 is not greater than 9. So this is positive. If and only if this we know is absolute value of x minus 1, this is greater than 3. If and only if this is greater than 3 or its negative is less than minus 3. If and only if x is greater than 4 or so if we multiply both sides on both sides by minus 1, then we have x minus 1 greater than 3. What is happening here? I think this is wrong. Either x minus 1 is greater than 3 or x minus 1 itself is less than minus 3. not its minus. Okay, so that means this was correct. X is greater than 4 or x is less than minus 2. Okay. So we will write the conclusion afterwards. Let us consider the other case then. So here either x has to be greater than 4 or x has to be less than minus 2. Now this is under the condition that x is positive. Now if x is negative, then x by 2 greater than 1 plus 4 divided by x is equivalent to, now if we multiply both sides by 2x, we are now multiplying by a negative real number, so the inequality will be reversed. So x square is less than 2x plus 8. So it's almost like the previous case, only the inequality has a different direction. So that means we have this square is less than 9 if and only if this is less than 3. So add 1 minus 2 is less than 4. Okay, so the set of all x for which x by 2 is greater than 1 plus 4 by x is. Okay, now we are going to write the set. In this case, we obtain these two inequalities. That means if x is positive, then either x is greater than 4 or x is less than minus 2. This one clearly is not true, because if x is positive, x simultaneously cannot be negative. So when x is greater than 0, x has to be greater than 4. So 4 comma infinity. And when x is less than 0, then x is greater than minus 2 and less than 4. Since x is already less than 0, so that means the other interval will be this. So only when you take x from this set will this inequality be true. Otherwise it will not be true. So that means x either has to be negative, being simultaneously greater than minus 2, or x has to be greater than 4. So let us now verify this by considering some, unless we have made some terrible mistake in this calculation, this is the solution set of this inequality. So we can just take some 2 or 3 values of x and see what we have got is correct or not. So we take one value from outside of this set. So we take x equal to 3. So if you put x equal to 3, what do you get here? 3 divided by 2 on the left hand side. On the right hand side you have 1 plus 4 divided by 3. Now 1 plus 4 divided by 3 is 7 by 3. Now is this greater than this? No. This is in fact less than this, because you see 3 times 3 is 9, whereas 2 times 7 is 14 and 14 is greater than 9. So yes, if you take x equal to 3, then this inequality is not true. Let us take one more value, x equal to say 0. 0 is also not in this set because this interval is an open interval. So we cannot take 0 at all, sorry. 0 is not that does not come at all. So let us take x equal to 1. If we do that, we have 1 by 2 on the left hand side, whereas on the right hand side we have 5. Clearly 5 is not less than 1 by 2. So yes, okay, we are fine. Now if you take a very large value, say x equal to 10 suppose, then what happens? If x is 10, then 10 by 2 is 5. On this side we have 1 plus 4 by 10, which is a number lying between 1 and 2, and clearly that is less than 5. So we have no problem with this. Okay, we were unable to take x equal to 0. However, we can take x equal to minus 2. There is no problem in doing that. However, if we take x equal to minus 2, what do we get? It's a point outside of the solution set. If you do that, we will have 1 minus 4 by 2, that is 1 minus 2, which is minus 1. Here, however, you have minus 2 divided by 2, which is minus 1. Minus 1 is not strictly greater than minus 1. That's why minus 2 cannot be taken inside the solution set. If you take x equal to 4, then 4 by 4 is 1. So the right hand side becomes 2. And the left hand side also becomes 2. 2 is not greater than 2. So that's why 4 is also not a part of the solution. So this is our this is the set of those x for which the given inequality will be true. Now finally there is one more such exercise. Graph the functions fx equal to this times. Both of the functions are problematic in this sense. 3 divided by x minus 1 and gx equal to 2 divided by x plus 1 together to identify the values for which this will be less than 2 by x plus 1, and also confirm your findings in A algebraically. So part A you already know, you have to go to Desmos and find out the graphs. From the graphs you will be able to figure out the required values of x. But what about algebraically? So here also, depending on where x is lying on the real line, we will have cases. So this is case 1. Note that x cannot be minus 1 or plus 1, because those things will create zero denominators and we will be in a problem. I mean, at that point things will be undefined. So x can be strictly less than minus 1. Let's start from the negative side. X is strictly less than minus 1. Then okay, now if x is less than minus 1, what does it mean? It means x plus 1 is negative. right? At the same time, since x is less than minus 1, x itself is a negative real number, so x minus 1 is even more negative. So here both the denominators are negative. That means if we take their product, the product will be positive, and if we multiply both sides by that product, the inequality will not change direction. So multiplying both sides by x plus 1 times x minus 1, the inequality stays the same. Okay, so now this is equivalent to what? X minus 1 will cancel out, so we will be left with 3 times x plus 1, that is 3x plus 3 is less than, here 2 times x minus 1, 2x minus 2, or x is less than minus 3 minus 2 minus 5. So this is the first case. The second case is this: x is greater than minus 1 but less than 1. Note that, keep in mind, x can be neither of these values. Okay, otherwise we will have 0 denominator. So there x was to the left of minus 1, here it lies to the right of minus 1, but x continues to be less than 1. In this case, if we multiply both sides by this product of the denominators, then that will be okay, since x is less than 1, so x plus 1 is greater than 0 and x minus 1 is less than 0. From these inequalities we can directly infer that x minus 1 is less than 0 from the second inequality, and from the first inequality we get this. So one of them is negative, the other is positive, so the product will be negative. This time the inequality will get reversed. So if and only if this is greater than this, if and only if 3x plus 3 is greater than 2x minus 2, if and only if 3x minus 2x is x, which is greater than minus 5. And finally we have this one, that x is greater than 1. If x is greater than 1, then both x minus 1 and x plus 1 are positive. Because if x is greater than 1, x is then from here itself you can see that x minus 1 is positive and x plus 1 is positive because x itself is positive, so adding 1 to it will make it even more positive. Okay, so in this case In this case also this product is positive because the factors are positive. Here it was positive because the factors were negative. So this time also the inequality will not change direction. Okay, so let us now see what we have done and what we have with us now. If x is less than minus 1, then x has to be less than minus 5. There is no problem with that. If x lies between minus 1 and 1, then x has to be greater than minus 5. Okay, but if x is greater than 1, then x simultaneously cannot be less than minus 5. So this case does not arise. This case, if x cannot be greater than 1, okay, it will always be less than 1. So that means the set of all real numbers x for which the given inequality is true is the set of all x that has been determined by these conditions. So the first one is, if x is less than minus 1, then x is less than 5. That means minus infinity comma minus 5. Okay. If x lies in this interval, then x has to be greater than minus 5, which anyway is true. Union minus 1 comma 1, and the other case, of course, it does not occur at all. So here for this problem, for this exercise, this is the solution set, and just like the previous case, the previous problem, for this one also let us take a few values of x and check whether we have found the correct thing. So this is our inequality. Let us put the boundary values. We cannot put either 1 or minus 1 because that will create problems. We can put x equal to minus 5. If we do that, what will the left hand side be? 3 divided by minus 5 minus 1 is minus 6. So this is minus 1 upon 2. And the right hand side is 2 divided by minus 5 plus 1 is minus 4. So this is also minus 1 upon 2. This cannot be strictly less than this one. So minus 5 is not a part of the solution set. Fine. If you take anything less than minus 5, say for the sake of easy calculation we take minus 6 suppose, then we have this. Now is this inequality true? If we take minus 6 here, we will see minus 5. At once it's a little bit difficult to see that this inequality is true. So you simplify it, you multiply both sides by minus 1. That will change the direction of the inequality, and then you just do cross multiplication and see if it's correct. 3 times 5 is 15 and 2 times 7 is 14, and 15 is greater than 14. So yes, it is correct. Now if you take a value in between minus 1 and 1, say we can take x equal to 0. There is no harm in taking x equal to 0 now, because in the denominator we don't have x alone. We have x but not as a factor. So doing that, we get the left hand side is minus 3 and the right hand side is 2. So yes, this inequality is true. But if you take for example x equal to minus 2 say, which is outside of this interval, lying between minus 5 and minus 1, then here you will get 3 divided by minus 3, which is minus 1. On that side, what did we take? Minus 2. So this will be 2 divided by minus 1, that is minus 2, and this is less than minus 1, not greater than minus 1. So for x equal to minus 2, the inequality is not true. So we can say with confidence and on the assumption that whatever we have done here, our logic is correct, we haven't made any mistake. So this is the solution set. So I urge you to go to this website and plot these functions and see that whatever we have found here algebraically is actually also true geometrically. Okay, we have been asked to confirm our findings algebraically, but we have actually found the solution sets in both the cases algebraically, and we now have to confirm our algebraic findings geometrically by taking the help of some sort of graphing equipment. I planned to start another section, but I am not feeling quite well tonight. So I will end the video here, and in the next calculus video we will start a new section, lines, increments, those things. Okay, so with this I sign off. This is me, Lucifer, from A Mathematical Room. Have a nice night.